have distance, rate, and time. So if painter A, it takes painter A 4 hours to paint a certain area of the house. So it takes him 4 hours. And then it takes painter B 6 hours to do the same job. How long is it going to take them working together to get this job done?
2 hours.
Okay, so I'm hearing a lot of guesses. There's a mathematical way to do it, and we're going to view this as fractions. So what's the rate that painter A would take to finish the whole house himself? 4. Okay, so his rate is 4. So here I'm going to have a painter A fraction, and his rate is 4. So I'm going to put for the 4 in the denominator, as this takes how long it takes him to work. Okay, so for example, if he only worked 2 hours, he would only have half of his project done, because 2 over 4 reduces to a half. If he works 4 hours, he would have the whole thing done. Okay, now he's working with somebody else. So he's working with painter B. So they're working together, so we're adding. Okay, what's the rate that painter B works at? 6 hours. Okay, so if painter B, working alone, worked for the whole 6 hours, he would also be able to finish the house by himself. So the whole goal here is to finish this project. So we're going to have it equaling 1, where 1 represents that the whole thing is completed. Okay? And then we want to find out how long they're working together. So they're going to be working together the same amount of time. So we'll put x and x in the numerator. So that numerator is representing how long they're actually working together on a project. The denominators are their individual rates. And now we just have to solve this. So how would we solve an equation like this? Same denominator. So 4 and 6, what will be our same denominator? 12. You could use 24 if you wanted to, but we'll use 12. Okay, so what do we have to times the 4 by to get 12? 3. And the 6 by 2. Okay, so now are the denominators the same? Yep, they're both 12. So we have 3x plus 5x. Oh, 3x plus 2x is 5x. Oh my. Over, and our denominator is 12 is equal to 1. And then how would we solve this for x? Times by 12. So 5x is 12. Divide by 5, so x is 12 fifths. Or 2 and 2 fifths hours. I don't care if you leave it as a mixed number or if you write it as a fraction.
Okay, so each one of those are...
Is there a button on a calculator that changes it?
Yes, if you just put 12 over 5 as a fraction and then enter, it will go to a mixed number for you.
How did 5x over 12 turn into 1? Sorry.
It didn't. We're solving the equation, so here it was equal to 1, so here it's still equal to 1.
So then you put it in the thing.
So we solve for x.
Yep.
So we times by 12 on both sides. So then we got 5x equals 12, and then we divided by 5 on both sides. So we got x is 12 fifths. Okay, so let's do the next one. So Bobby can type a 25-page paper in 4 hours. And last month, Bobby and Sandra typed a 25-page paper working together in 2.5 hours. How long would it take Sandra to type a 25-page paper alone? So what is Bobby's rate? Bobby's rate is 4 hours, so he can type it in 4 hours. So that's his rate. What's Sandra's rate? It's an x. We don't know it, so we're going to put it as an x. Okay, it should equal 1 because we want this whole paper to be done. And how long are they working on it together? 2.5. So 2.5 will go in the numerator. Now how do we solve this for x? Yeah, we got it. Okay, so we got to get it like denominators, or we can notice where's our x right now? Our x is only in this fraction, right? So could I subtract 2.5 over 4 over? Yeah, probably be the easiest way to do this one. So we're going to subtract 2.5 over 4 from both sides. So then we are left with 2.5 over x is equal to, what will be 1 minus 2.5 over 4? Yeah, that's like 4 over 4 minus 2.5 over 4. So 1.5 over 4. All right, then how do we solve this? Okay, so x times 1.5 is 1.5x is equal to, what's 4 times 2.5? 10. Divide it by the 1.5, and what do we get for our x? Yep, 6 2/3. So 6 2/3 hours is how long it would take Sandra to type it by herself. Is that okay? All right, so let's look at a couple others here. Focus on this. Okay, it takes 15 hours to fill a pool with water. It takes 25 hours to drain it. If the pool's empty, someone left the drain open, how long is it going to take us to fill the pool? Yeah, now these efforts are working against each other, right? Because the water, we're trying to fill it, and it's being drained at the same time. So if we're working against each other, not with each other, what sign do you think is in the middle? Yeah, now we're subtracting instead of adding. So to fill the pool, what's the rate to fill the pool? 15 hours. What's the rate to drain the pool? 25 hours. They're working against each other, so we put a minus sign in between. And we want to find out how long it's going to take. So we'll make the numerators both x. Yep, it takes longer to drain than to fill. It's a small drain. Okay, so what would be our common denominator here so we could solve this? 75, yep. So how can I make 15 into 75? Multiply by 5. How can I make 25 into 75? Multiply by 3. So the denominators are now the same. And our numerator is 5x minus 3x, which is 2x. Now how would I solve this for x? Times by 75, so 2x is equal to 75. Divide by 2. So what's our x here? 37 and a half hours. Train A. Train A is going 6 kilometers per hour faster than train B. Train A travels 100 kilometers in the same time it takes train B to travel 80 kilometers. Find the speed of each train. So now we have 3 types of variables here. We have a rate, we have distance, and we have time because they're traveling in the same time. So anyone remember the formula that relates distance, rate, and time to one another? Distance equals rate times time. Okay. Now, the key to these problems where we have distance, rate, and time is to figure out which of those 3 variables is the same. Okay, so the distance will be the same, the rate will be the same, or the time will be the same. So in this particular problem, which of those 3 variables is the same? The time is. It says right here, same time. So since the time is the same, we want to solve our equation for time. So how do we solve this for time? Yep. Okay. So our time for train A and our time for train B are going to be the same. Okay, and it's going to be distance over rate for both of them. So for each of these, we just need to set up distance over rate. So for train A, what's the distance train A travels? 100 kilometers. Okay, what's the distance train B travels? 80 kilometers. And then we know a little bit something about the rate. We know that train A is 6 kilometers per hour faster than train B. Yep, x plus 6 and x. Now, if you want to even make these into b's instead of x's, that's perfectly fine as well. Right? Doesn't matter. Okay, so let's solve this now. So how would we solve this?
Same denominators.
Oh, they're already equal, so we don't need to do that. Cross multiply and solve it. So we have 100 times b is equal to 80b plus, what will be 80 times 6? 480, yep. How do you solve this then? Subtract the 80, so now we have 20b is equal to 480. So it's b equal to 24. So train B is going 24 kilometers per hour. That's why I changed the variable to b, because at the end we know exactly which train is traveling at that speed. Okay, so if train B is going at 24 kilometers per hour, what's train A going at? 30. Yeah, 30 kilometers per hour. Is that okay? They're kind of slow trains, but that's all right.
Well, maybe they can